Okay, we are live. It's May 29th, 2014, 11 a.m. on Thursday. This is now the new time that seemed to work better for a lot of people. So today we're going to be talking about handling failures. When is it good to use stale data? When should you give errors? And there's a bunch more subtopics there that we can go into. But just at a high level, as a DBA, what do you do about handling errors and what kind of things can you push for? And then probably a little more talking about sharding. We've got Morgan Tucker here again today, so maybe some more talk about Fabric, which just went. Did it go GA yet? It's going GA?
Yeah.
Morgan just muted himself as he went to talk. But yeah, so we'll hear about that too. But we're actually going to start with Shlomi, who has this really cool tool that he wants to demo. But
cool.
Before we get into that, let's do a quick round of introductions. So my name is Jeff. I'm a DBA at Box. Morgan, if you want to introduce yourself.
Sure. I'm Morgan. I work for Oracle in the MySQL community team.
Okay, Sherry.
I'm Sherry Cabral. I work for Mozilla as a DBA and team lead of the DBA team here.
Okay, and Shlomi.
I'm Shlomi Noach. I'm engineer at the infrastructure team at Outbrain.
Okay, so without further ado, Shlomi, if you want, go ahead, take it away.
Cool. So I want to show off a tool that's going to be announced in a week, maybe 2 weeks. It's always the documentation that's taken the most time when releasing an open source project. So this is a tool I've developed at Outbrain just as I returned from Picona Live. I was inspired by a lot of talks, and I saw a lot of great talks about automation and stuff, and there were a few requirements for automation back at our company, and the tool I came up with is called Orchestrator, and I'm going to show it off right away. So let me work out the screen share. Can you see the screen?
Yep.
Okay, cool. So maybe I can make it a bit larger. Does that make sense now?
Yeah, it looks good, and you've got the floor. Camera will stay on you now.
All right, cool. Okay, so what Orchestrator is a tool to visualize and manage your replication topologies. What you're seeing right now is this tree of a master and 3 slaves, which for the purpose of this demonstration is a sandbox topology on my own laptop. But we already use this on our production servers, so you could see like fancier topologies, like lots of slaves, like dozens of servers all around. And the tool does a few things for you. The first thing is that it visualizes your topology. We're maybe used to see stuff like PT slave find from Picona Toolkit and stuff like that, which does like an ASCII visualization of our topology, and this is a whole lot more sophisticated visualization where you get stuff on GUI. That's for starters, but the real fun is that if you want to change your topology and you want to move that slave below that slave, well then it's just a matter of drag and drop. And there you go. You've just modified your topology. And on that, we've already saved like days of hours, days of man hours at work. It's practically saved the day a couple of weeks ago when we had a major data center crash, and we had to rearrange our entire topology. So moving slaves around is not easy. There used to be a tool in MatKit called ptslave move. It's not supported anymore. So this is a new tool to do that. It's not just GUI, it's also command line. You can run everything from command line, but the fun part is the GUI part. And as opposed to other tools, it allows you to keep a state of your topology. So, for example, if I were like to take this slave right now and stop the slave. So now this slave is not replicating, and obviously that slave behind is not replicating as well. And most tools that would interrogate your replication topology would start with the master and just drill down and see whatever slaves they can find, and what's there is there and what's not there is not there. And most tools would just find the master and that slave because this one is not replicating. Well, Orchestrator keeps a state of all your servers. So it remembers that this slave used to replicate from that master, and until it says otherwise, until it says, well, no, I'm actually replicating from this machine, or until such time, like 7 days has passed and it's never been, accessed, so we may as well forget it. Maybe the machine went down. Until such time, it's still on your topology. You don't need to have everything connected in order to know what's your replication topology. So one of the nice things about this is that Orchestrator is going to protect you when you move slaves around. So for example, if you want to move that slave behind that one, it's going to check a few stuff. It's going to verify that this one has binary logs enabled, log slave updates enabled. It's going to check that if this one is row-based replication and that one is statement-based replication, it's not going to work out, so it's not going to allow the move. If this is 5.6 and this is 5.5, well, you don't want to replicate from a higher MySQL version to a lower one. It's not going to allow the move. So it keeps you safe. It keeps you safe both in terms of is it right to replicate from this server to this server, and it keeps you safe in terms of, well, how do I configure the binary log file and position. I should mention that this tool works with good old MySQL replication binary log file position, so it doesn't work with GTID. With GTID, this stuff is much simpler, right? You just point the slave to a new server and say keep on from there. But we're not using GTID, and actually most companies I've met at Become Live we're not using GTID, so this is still very relevant to a lot of companies. So. So I guess this is it. You want to manage your topology. You just, okay, I can move this under that one, or I can promote it up here, and that's it. That's what I want to show off. So I'm going to announce it in a week or so.
Cool. So I have a question, Shlomi. How does this deal with master-master and like multi-master topologies?
Right. Okay, so multi-master topologies, as in MariaDB 10, are not supported, and I don't plan to support it. It's probably not going to work out. Master-master, like circle or master-master replication, is supported. The only catch is that it won't visually present the circle, right? So it's going to show, it's going to pick up on one of the two masters and just run from there. It's going to mention that the other one is also a master, but visually wise, it has to present a tree, right? There's no, I didn't find a component that will draw this circle of master-master, but it works well. We actually have that kind of topology and presents it pretty well.
Cool. So if I actually want to set this up, can I get at the code and get this going already, or is it going to be a little bit?
Yeah, the code is already available at GitHub, so at github.com/outbrain/orchestrator. The documentation is still not committed mostly, so you wouldn't know how to execute it. So in just a week, maybe two, I'm going to have all the documentation set up. This is a Go language tool, so almost zero dependencies, no Apache, no PHP or stuff like that. You just need one MySQL as backend to store the state of your topologies. Everything is audited. All the operations are audited. You can put servers in maintenance mode and out of maintenance mode, so you get a history of everything that's been done, what's been moved from where to where, what's not been seen for some time, stuff like that. So all that is being written to a backend MySQL server. So that's the one requirement or dependency that you have to set up before running Orchestrator.
Does no one else have questions? I mean, I'm just writing down notes right now. I mean, if anyone else wants to like nudge Shlomi, ask him questions about it.
I'll have to take a look. One thing I'm curious, Shlomi, if this is part of the problem or not part of the problem. Resource transfer, like IP addresses or moving parts of the application has to.
No. So this is not like a master failover or stuff like that. That has nothing to do with it. That has to do with how to manage your replication topology. This is not a master failover. So no virtual IPs, no playground, no playing with IPs or stuff like that. I do require that the IPs have to be resolved, so there has to be some DNS support anywhere within the system, because we're using a lot of aliases, and a specific server could be named like in 4 different ways. So I always use the CNAME, normalize the CNAME, and use that. So not only is there no playing around with IPs, I need to know that I can resolve any name and any IP of any machine.
Makes sense.
Cool. So I'll announce it next week or in 2 weeks, and it's pretty cool. So you should try it out.
Okay, cool. Thanks very much, Shlomi.
Thanks.
Okay, so onto the big topic for today, which is handling failure. And so specifically just for everyone, in your day-to-day and just in your experience, how do you handle failure, when something goes wrong with your database? If you want, maybe present a situation that you've encountered and how you remediate it. But also just kind of drilling down to, I mean, this is stuff that, you typically, if you're writing the application and you have control of it, changing those parts of it to be a little more graceful, or maybe just things that you actually have to work with an engineering organization to help make things play along nicely with MySQL to handle failure better. Because, I mean, we're in a world where we run hardware, and hardware is prone to break. That's what it does. And so making sure that the experience that you're serving, comes back in a nice fashion. So I just kind of like normal, just want to open up the floor. Anyone, feel free to chime in with your experience or things that you've had to deal with and how you've worked around them.
So,
Go for it.
okay, I'll just fire up a few stuff that we've discussed previously here on DB Hangout. So, on the MySQL failure side, we try to put as much as we can behind proxies. So we use AJ proxy, and it just decides which slaves are available and which slaves it can use, and just points me to the right machine. A couple weeks ago, we had a power failure in a complete data center. It just crashed unannounced. And we have 2 other data centers from which we serve. So we have total in 3 data centers, and it was an amazing thing to see how an entire data center crashes and serving still goes on. This wasn't as fun as it may sound, but it just worked. We had a lot of work recovering all the machines because the UPSs didn't hold. The data center completely broke down. Nothing worked. So a lot of machines crashed and stuff like that. But the fact that you can lose an entire data center, like hundreds of machines, and still keep on running, that was an awesome thing. So it's on the grander scale. How do you control the traffic to your website? Where do you point them to, etc. Whenever we have a MySQL failure, we don't argue. We just, if we need to, we reformat the machine, or whenever we suspect data corruption, we don't do PD table sync. We just receive the slave from another. We just copy the entire data set again and go on. It takes time, but it's the safest for us. So that's what I have to say on the MySQL side.
Yeah, that's good. And I was going to say, I mean, we're actually not using HA proxy in front of our MySQL servers right now. We have some of that logic built into our applications so that it knows to kind of do read-write splitting and send certain traffic to the master and certain traffic to the slaves. And it's also cognizant of multiple slaves and being able to kind of go around and pick one. And some other things that we've more recently, probably over the past year, have put into the application are things to be more cognizant about database health. And so something that we had talked about previously was, how do you health check your system and make it avoid thundering herd problems? Because that was a case where, a couple years ago, a request would come in, and if it was a read-only request, we would send it to the slave. But if the slave had non-zero lag, the request would fall back to the master. So if we ever got in a situation with a lag slave, we started destroying the master. And so eventually that was changed, and we added this health checking service. So before you go to a server, you check the health check service. Does it say that the MySQL instance is up or down, and perhaps other information. And then with that, the application makes a judgment call. Can I talk to the server, or should I fail the request early? And then, the next layer after that is then prioritizing requests, or maybe having back-off logic built in. So it's one of those, building the application's easy, and then iterating to make it more efficient and more effective is obviously more of the work. And looking at other technologies that have been built already, and a good example is just like TCP/IP. There's back-off built into that, and it's exponential, and it allows things to get into a state of recovery before it goes back and tries again. And so just exercising those same concepts in a higher level of the stack can allow you to get kind of the same wins. But yeah, I could dive more into this. I'm curious if other people, Shiri maybe, or Morgan, just like in your day-to-day, when things, is there logic built into the applications that you've seen to fail the request or to defer the request somehow, or how does that work for you?
A lot, but not all of our applications are set up so that they can retry without a problem, like especially our build bot servers, right? So if they'll have like a build and it will process some of the data, if something happens, it can just retry the data. Not all of our applications have that though, and that can be a problem if we're doing things like failover. One of the problems is we don't have a lot of insight into the databases, so there's just documentation on like, oh, if you're doing this, just kind of give this person a ping on IRC. If you're doing this, you have to, shut down the service, move stuff over, turn it back on again, so that because there are applications that aren't fault tolerant. A good example of one of those is Confluence. We use Confluence, and it's just not fault tolerant. And so the last thing you want to do when you're doing some failovers or something like that is have your documentation go away in Confluence, or have any of your Jira bugs go away if you're using Jira. So different applications handle things differently, and of course we have a wide range of people who are coding. So all of those little tools and applications are different. They all use, for the most part, I think they all use load balancers so that we can change things transparently underneath. Unless of course you're something like Confluence, which you have to restart if you change the database. So that's a way in which it's too fault tolerant, right? It tries to make sure that you haven't messed up a database, or that nobody's moving databases behind that. But yeah, so there was something I was going to say with that they go to a load balancer, but they don't always use. Many of our applications will read-write split, so we have a read database and a write database, but not all of them use that too. So there's different levels of what's being coded.
Okay. Yeah, and that's a story I've been hearing from more and more people. And just like HA proxy has actually become a very popular thing, it sounds like, for folks, that you run all of your traffic through HA proxy before. Shiri, I think before you had also mentioned that you're using a hardware load balancer. I can't remember what it was called, but it does the health checking on MySQL.
I think it's called Riverbed now. It used to be called Zeus, whatever that one is. Yeah, we use that. We have a virtual IP. So that they just go to the virtual IP of, read database, write database, and then we can change everything underneath, without having to do any application work. Okay.
So does anyone here have an ability built into their stack that allows? So I guess a better question is, does anyone here run master or multi-master? I think that it feels like an overwhelming yes, probably. So with that, when you have an issue, do you just move from one master to another, or do you kind of shuffle slaves around with the master? Is that automated for you yet? Things like that. And I mean, from our perspective, there still needs to be a person to intervene and check. But yeah, it's the kind of the hot standby that you can move traffic over to.
We're in the same boat. We do things manually, and sometimes it's a pain when we're doing a switchover and we have to reslave everything. But we just haven't automated it yet. We have taken steps to start using GTIDs in some places, so that failover is easier. But that's not everywhere.
Yeah, and Shlomi, I'd love to hear what you guys do.
Yeah, although we have one configuration for a master, this is for the sole reason that we need geographically co-located master for different services, but we don't actually use master for, we don't fail over the master. We haven't done it in ever since I came to work here a year ago, so we don't fail the master. And we don't do anything with the master that's not an insert, update, or delete, anything, ever.
So you don't actively write to both? You just write to one, but they're pre-configured?
Oh, you mean with our master configuration? It's actually not a real master configuration. There's different schemas for different services that are completely unrelated, and they have to be geographically co-located. We're working actually to bring them all into the same data center so that we can get rid of the master. I don't like it.
So just again to clarify, Shlomi, so with that master that you currently have, though, inserts or changes on each individual master never operate on the same set of schemas or tables. Is that a correct?
That's right. That's right.
Mm-hmm. Okay, yeah, because that was going to be my next thing was, if you are in a state where that happens, and Shiri, I'm sure you might have encountered stuff like this, but when you move from a master to kind of your standby master in the master topology, maybe due to an issue, maybe the master that you're currently on suffers some sort of outage and crashes. And so you move all traffic over to the new one, to your other master, but once the old one comes up and things that were in flight, some of those in-flight transactions get rolled back, maybe some of the things that were committed to the binary log finally start getting shipped over, and then you have to deal with key conflicts that might arise. And so, usually, the canned response is, well, you should have your auto increment offsets set to different numbers, like 1 on one master and 2 on the other, so that it's odd or even.
I don't think that ever works. That only works for inserts. If you've got an update or a delete, the same problem exists unless you specifically hash for odds and evens on which server you connect to. But then you don't have HA because you have to have both available at once.
Yeah, and actually an interesting problem that we've encountered is if you have unique key constraints on any tables, those step out of that realm and they have to be reconciled. A good example is maybe you have a unique key constraint on email address or something like that. So if someone was mid-flight changing an email address to one that is valid, and then when that server crashes and they end up retrying that request on the new one, when you finally come up and replicate, you now have a conflict that you have to reconcile. That is ultimately a conflict that you can, accept, skip, and it's safe in that respect because it's a known thing that's changing to the same value. But there are other cases where, it can be different, and that's something that has to be reconciled.
Yeah, I think in most cases people throw away the failed machine, so it has to be a reimage to come back in.
Yeah. Absolutely. Jeff, this reads to me like been there, done that. Years ago, we used to play with MMM. That was the high availability solution back then, and it would supposedly take care of all that stuff, turn the slave, a co-master into read-only, only then release the read-only from the other master, supposedly make sure that everything is caught up. But, there's always catches, like all these uniques, and I completely agree with Morgan. The moment when we even suspect a single row is not intact, we just destroy the server and completely take a new snapshot. We don't argue with this stuff anymore. We do auto increment stuff. Just forget it and make it new.
That's a good methodology, and I mean realistically too. Getting to GTIDs definitely helps deal with this and allows us to remove the necessity for something like master, because then you can easily fail your slaves around.
So Semi-sync and lossless semi-sync are two new features from MySQL as well. So
Right.
that can help. Semi-sync until 5.7, what can happen is that the master can have something committed, and the slave doesn't have it, but the application wasn't told that that write was successful anyway. So that can be a problem, but in 5.7 there's an option where the master can wait until the slave is committed before it commits it itself and gives acknowledgement to the client. So that will be nice when that goes GA. I think it'll help some people in this situation.
I'm actually curious, has anyone else used, actually I'm not sure if anyone else here is running 5.6 yet, but does anyone use semi-sync?
Semi-sync came in 5.5, but
That's right.
it's been improved over time as well.
We're using 5.6, but we're not using semi-sync just because a little bit of replication lag isn't going to kill us. Even on something like the Bugzilla server, it just doesn't kill us that much. And one of the topics was how do you tolerate replication lag? Some applications are more tolerant than others. For example, we have a service, a database that replicates add-ons. It's actually a cluster that we have the add-ons cluster, right, for add-ons in Firefox, and then we have a cluster that's a slave of that cluster that just replicates some of the stuff, not everything, and it's called version check, and it checks your version. Whenever you open up your Firefox, it checks to make sure all your versions are compatible. So if there's replication lag on that, unless there's something that just got upgraded, some add-on that got upgraded for security that like really super needs to be it, like it could be even a day out of sync and nobody's even going to probably notice or complain. But then other things like Bugzilla, if you're 5 minutes out of sync, people are going to notice and complain. So it depends on the application, and that's one of the reasons we haven't put in semi-sync or replication is that it hasn't been necessary to have the overhead on commit. Because we can deal with a little bit of replication lag.
It's funny that you mentioned with like a 5-minute lag on Bugzilla, and people will complain, and it'll probably take 5 minutes for their bug to show up about that. Anyways.
Well, we've recently gotten a lot faster. We converted one of the reasons to go to 5.6, and Morgan, you can correct me if I'm wrong, but I'm pretty sure this was 5.6. We changed our full text table to EnoDB. And that improved speed a lot.
Yeah, it's interesting. I have seen some benchmarks that show in some cases the InnoDB full text search is a lot faster. It surprised me.
Yeah, we haven't changed any code or anything. We just changed from MyISM to InnoDB, and it's just tons faster.
I've been curious about trying that. We don't have a lot of, I think I can count them on one hand, the number of full text things that we have. And I think the big one is actually Puppet. The Puppet database schema has a full text index key, but it doesn't use any of the full text type queries on it, so it doesn't actually get as much of the benefit out of it. And we ended up just converting that table to InnoDB on 5.5, but I'd be interested to see how it would look in 5.6, especially if it properly uses the indexes for it. But yeah, so Shiri, you mentioned the slave lag and being able to tolerate it in the application, and I think that's actually one of the more important points. And I mean, semi-sync replication definitely helps there, where you can wait, kind of block the commit on your master until a slave or something has it. But you also take an increased latency there on your commits. And I mean, if you already have stuff, wow, I can't remember the configurable right now. It's the one where you commit every write to the write-ahead log. I am drawing a blank on this.
InnoDB flash log at TRX commit.
That's the one. But yeah, if you set that value so that it flushes on every single write that comes in instead of on the spinning time, I mean, you're already taking that I/O hit, and if you have that set on all servers in the topology, then you're waiting for a semi-sync replication to get down to the slaves and do that as well. I mean, you're incurring that overhead along the way.
What's interesting, though, Jeff, is that by turning on semi-sync, potentially you could turn that setting off. So you could have durability based on the network promise of durability. So I don't know.
The network promise.
I don't know many people who really toyed with that till its full extent. But you don't necessarily need a promise at every level, as long as there's one level that you can rely on consistently. And so
that is true.
You could potentially turn off sync bin log, and you could turn off to flush log it to your x commit equals 1 if you were using semi-sync. And on a low latency network, it might be 0.1 milliseconds. That's pretty low for a network round trip. On a higher, it might be half a millisecond. But if you were using crappy hardware, it's going to be a couple of milliseconds to maybe sync to disk anyway. It's interesting. I think there's a lot of opportunity for improvement.
That'll be interesting to see. And I mean, dealing with having to wait for data to be committed across multiple nodes before you can send a response is something that's already in other systems. Like I know for me, we also have a lot of HBase, and that's something in HBase ultimately when you do a write to there under the hood on the HDFS distributed file system, you're actually getting a commit to 3 different nodes across the network, and so you're accepting more latency there.
Yeah, MySQL cluster too, with number of replicas. Just about everyone's using 2 as the count, but to make sure that it's memory synchronous in a couple of nodes, and then the commit is acknowledged.
Yeah. So actually, Shlomi, I wanted to sort of raise a question to you about replication lag and how it's tolerated in the application.
Right. So our services are required to tolerate slave lags. We've done a good job in reducing the slave lag in the recent months, and we typically have less than 10 seconds lag at any given moment, which is nice. There are some hours where we don't get any higher than 1 second lag, which is really nice. But actually, our services are assumed to accept even 200 or 300 seconds lag. So they're supposed to continue working without lag. If they don't work without lag, it's an application problem, right? So that's how it goes, and it works well with the fact that again, it's like Shira described, it's very fault tolerant. So we've got we're working a lot with message queues, and all the jobs that our application needs to do are being brought from message queues. And if it tries to do something, maybe the lag is too high or whatever, the job just gets put back into the message queue, and that's how we recover from stuff like that. So replication lag could be such a case that if it does pass the 300 seconds lag, okay, put it in the message queue, we'll deal with it again. Typically, I would like to see better. I would like to set an alert for 10 seconds lag, but I can't manage to guarantee that we'll never get these lags. So we drop this on the engineers.
It's interesting to hear your number of 300 seconds. I think there's 2 similar but different problems there with replication lag. One is that you can get this spike where it's 0, then it's 10 seconds, then it's 0, then it's 10 seconds. And replication being single-threaded, at least until 5.6, and still better in 5.7. If you have a 10-second update, everyone's going to be behind for 10 seconds if they read from a slave at one point in time.
Yeah.
So what I've seen is frequent is that you have to chop up updates and deliberately splice them so that no individual DML statement is ever longer than, say, a second. So yeah, that's a common approach to do things.
So we have multiple MySQL topologies. One of them is OLAP, where we do have such cases, but with our OLTP topologies, we don't have a 10-second update. That is something that is simply not allowed. And since we're mostly exactly. So since we mostly use Java and Hibernate and Spring, almost everything is done on the single row level. So it's rare that we get multi-row statements, and when we do have them, it's because we designed them to be so, to get better performance. But it's never a 10-second update. That is something we don't allow.
Yeah, makes sense.
So actually, I just joined. So we're talking about handling failures, and the one that we're on right now is specifically tolerating replication lag, and on the application. And so if you want to chime in about how things work where you're going, or from your experience. Ike, you are muted.
Yes, now I'm unmuted. Sorry about that. I'm late and I'm muted. But yeah, so similar to what Shlomi was saying, we try to keep our replication lag very, very low, as in, 0 seconds, 1 second. And given the nature of our application and the way things have played out, that's actually been not too much of a problem. But where the tolerance is very low, there are certain things where we'll read back from the master database, just to make sure that we always get fresh data. If there's a race condition or something where we're reading from a slave and it didn't work, we'll just read it from the master. But we try to avoid that as much as we can. So for the most part, we try to build in a little bit of tolerance for lag to at least give a good user experience. But on the other side, behind the scenes, we're able to keep our replication lag very, very low. With the exception of sometimes a remote data center, can lag for other reasons, just if the S tunnel goes down or something like that. Yeah, so that's what we're doing.
Okay, cool. Yeah, and something else I was going to mention was with our application, because for us, and maybe it's something that can be changed on the application level, but currently there are things that need to happen, like for security reasons and permission checking, that do need to make sure we're always up to date. And so we also have a notion of kind of amount of lag that can be tolerated. So if it's something that is absolutely, we got to make sure we don't do a bad stale read. Maybe that goes to the master, or we'll fail the request until it can get to it on the slave. Then there's another one where we can kind of deal with some amount of lag. So maybe certain things that kind of have to percolate through the system. We can have the application tolerate up to X seconds of lag. And then there are other ones where the lag actually just flat out doesn't matter. And yeah, it can if there's a day of lag or a couple seconds or what is it, it'll keep going. And something else that we had actually put in more recently to deal with some of these things was storing bin log coordinates from the master of a slave that it's going to talk to, so that when you go to the slave, you just want to see that the master information is the same when you maybe committed an action on the master, and provided that those coordinates have been passed in the bin log position, then you can do the read regardless of what the slave flag is.
Yeah, I've seen that a bit, Jeff, particularly when you do something on behalf of a user. You'll tag that user's session saying, don't touch a slave until it's up to this point, just after what I just wrote. So that way you don't have this serialization and the thundering herd where everyone has to go to the master now because the slaves are behind. Individual users are kind of setting little bits of tolerance. It gets kind of application specific, and sometimes it's hard to enforce those sorts of code changes on developers. You really need to own the app to do that.
Yeah, and this feature actually came most recently because of a distributed queuing system we have for asynchronous work in our application. And a lot of them would go to some action is done, we kick off asynchronous work to be done as a result of it. And then that worker will go and connect to the master to get the current position information, and then it would go to a slave and issue a select master position wait for those coordinates originally. And so that would cause issues where if there was any slave lag, you would have a stacking of these connections all running the master position wait function. And so ultimately the fix, which was really great, was just checking, when you spawn that asynchronous job, store the coordinates that the master was at when you did the action. And so when those jobs spawn up and talk to the slaves, provided the master hasn't changed, they can safely go about their day as long as that position's incremented past when the job was started. Because sometimes these jobs, typically they'll happen within a second or a couple seconds. But other times, maybe the job actually doesn't get started for an hour for some reason. Maybe the queue gets a little blocked up from something else. And the other thing is because it's distributed across machines, it's a little harder to kind of manage it there's no real good centralization point. So having this definitely helped us. And it was something that, using our tool, RainGauge, to collect the PT stalk output, we noticed that we had a lot of these periodic kind of stalls on our database slaves, and that always correlated to a flood of select master position wait. So this change definitely helped remediate a good chunk of that. Some of the other stuff we had around handling failures was how do you handle other partial failure states? And so I'd be curious, besides slave lag and maybe stale data kind of concerns, what other kind of partial failure states have you all observed in your MySQL setups and that your application has to deal with?
We run checksums on all our data, so I would say that one of the partial failure states would be when the data is not in sync. Sometimes it doesn't really matter. For example, if it's session data, if someone has to, kind of like log in again, it's not a huge deal. Some of it is like, hey, how did this get out of sync? There was something where we actually had a Bugzilla problem where we crashed, and then we ended up with like 6 entries different, but they're all related to one bug, and it's not a big deal. And it's something that happened like 2 months ago, and I'm still like, hey guys, how about you fix this? So, yeah, it's sometimes the data matters, sometimes it doesn't, but I would call that a partial failure state. We're a little bit blasé about checksums sometimes, I think, because nobody used them for so long. And so now when something is a little bit different, it's kind of like, well, if it's not the end of the world, does it really matter? And of course, the answer is, yeah, data integrity kind of matters. But, if we're doing something like, you only have to worry about it, right, when you're changing something to a master, or if the data is really out of date such that the read is different than the write. And when you're switching over, having people have to re-log in because their session data was stale is not that big of a deal.
What we have is partial data, partial failures are. It's not strictly a MySQL thing because we protect it with the layer above. So we get almost all of our data from our web servers. So anyone that's clicked a link or viewed some article, there's a service, a web server serving that person. And those web servers need to feed us with all this info. So most of our info comes from hundreds and hundreds and hundreds of web servers, almost thousands, I think. And they're just delivering flat files, log files. And these log files are either being eaten by Storm and Kafka, or they're being sent to Hive and stuff like that. But some server could be down, or some network cable, some switch could be slow, and not all files arrive at the right time. So that's where we get supposedly corrupted data. So the data is incomplete. So we set thresholds saying, okay, we have these jobs, and they need to scan the data and write some stuff to MySQL, and blah, blah, blah. And this job needs to have at least 98% of the data. 98% of the servers sent their data. Okay, go ahead and start working on that. And once the data is later, maybe an hour later, the rest of the 2% arrive, then this job wakes up again, and he says, oh, okay, there's the remaining 2%, I'm going to run again. So we have a fancy workflow engine. It's a tool of ours that manages all these jobs and all these reruns and decides who can run and all dependencies. So we take that above the MySQL layer, there's someone else that says, okay, the data is intact, the data is complete, the data is not complete.
Yeah.
Otherwise, we don't have data errors issues with MySQL.
I've had that problem with data not arriving guaranteed before you start a job. And the easiest way to solve it was just to make sure all jobs are idempotent so that you can repeat them later. And it sounds so simple, but that was not initially the case. And,
it's not simple at all. That's exactly what we do. Everything is idempotent, and of course, one of the crazy stuff about idempotent is that you need to delete some data before you start writing it again. What happens during that time? And there's a lot of gotchas with this, but it works pretty nicely.
So actually, Ike, I want to ask, are there other partial failure states that you've had to deal with?
Yeah, I mean, it's our specific case, a lot of it is, since we're running in Amazon, a lot of what we plan for is, what happens when there's latency in a certain availability zone or some kind of Amazon outage in an availability zone. So, we really worked hard on making sure that our replication topology help protect us against that. So, if we lose an entire availability zone, there's nothing unique there. We've got every redundancy in other availability zones. If it gets to the point that you lose a whole region, that's a case that we prepare for a little bit less, but we could, have degraded performance, and, the most important services are in other regions as well. So, for me, when I think about partial failures, a lot of it's about being in the cloud and being in Amazon and looking at, some of the outages we've had in the past, and just best practices on spreading out across multiple availability zones.
Now, is that spreading like just replicas across multiple availability zones, or do you actually do kind of multi-master topologies across them?
So we're master, active, passive. And intentionally the masters are in two different availability zones, and likewise with the slaves, those are in multiple AZs as well.
Okay, cool. Trying to think if there's any other partial failure states. Does anyone else have a partial failure state they'd like to talk about?
Sure, I might take a step back and talk about applications that can handle deadlocks. If they can't, it's hard to retrofit it because you've got these unknown unknowns. But if an application can handle errors that the database can provide it, it opens a lot of opportunities to have more elegant failover. And I've never really found a good answer for that. I've looked at, if I'm involved in an application early in development, putting a proxy in between the application developers and the database, and rolling a dice, and every 10th query gets a deadlock. But I've not done it yet. I don't know how it would work.
So do you have a more specific example maybe of like how retrofitting is more complicated with all the unknown unknowns? Because I'm not sure I'm actually coming up with one right now. Like I feel like, well, obviously you just wrap it in transaction, and then if it fails, it fails. But I guess it's a matter of trying to get the work done specifically.
That's the easiest way. If you wrap it in a transaction, and you can handle a lock weight and a deadlock the same way, and just present a user with an error saying, "Hey, try again," I think that's fine. That's sufficient. But if you look at technology options and you say that you wanted to do master-master, and we said with MySQL replication it doesn't really work so well. Well, the choices that a technology would have to be able to implement master-master is it can either do like optimistic concurrency control, where it gives you an error back if it failed, or it can just lock and serialize an operation and be pessimistic, and that would decrease throughput. I guess the way that I always describe it to app developers is imagine that you've got like two colleagues arguing with each other. Like, it's going to happen if people have to work on a team together, and there's a lot of concurrency. There's going to be conflicts, and the alternative to have a completely conflict-free environment would mean that no one can work together at all, and everyone has to work in serial, and it's just not a very production optimistic way of doing things.
So that actually brings up another good point around isolation levels. And does anyone here run an isolation level that's not repeatable read? All shaking heads.
I run a bit of read committed sometimes.
Go ahead, Sherry.
I've been in places where they do that, and no good can come of it. A lot of them, have either worked with Oracle before or whatever, and that's just the thing you do in the databases. No problem, change the level, that's fine. And there just always seems to cause some kind of problem. Usually with the data is not doing what they want it to do. I know that MySQL's version of repeatable read and Oracle's version of repeatable read are different and have different behaviors. So that ends up messing up people. But I'll let Morgan. It seems like he has something he wants to say.
Yeah, no, that's interesting to hear. That's all I was thinking. I do suggest it when you run with row-based replication. Row-based plus read committed reduces some internal InnoDB locking.
Yeah, that's something that we've definitely been chomping at the bit at. Is we want to enable row-based replication, but it's causing our bin logs to get a little too big. So we have to hold off on it still until we can address that. But
there's a fix in 5.6 for that, by the way.
Exactly. Exactly, and that's why it's turning into a bigger project because of it. But realistically, it allows us to change from repeatable read, and the biggest problem is whenever you have a query that does some sort of locking on a secondary index, it locks a large chunk of records with it, and then you get a lot more aggressive kind of locking behaviors. And it's actually to the point that we have a set of tools and monitors around just locking in MySQL that looks for heavy lock behavior. And it's one of those we'll be running InnoTop and you'll see, why do I have an update statement that is taking 40 seconds and then all of a sudden it hits 50 seconds and it goes away. And, realistically, that's actually that query probably gave up on trying to get a lock, and it's potentially because of another transaction having locked some chunk of records, or maybe another query that just locked on a secondary index. And so being able to do read committed allows you to get away from some of that nasty locking, but it's not a safe thing to do when you're running statement-based replication. So we've got about 8 minutes left. I think does anyone else have kind of a last partial failure state that they'd like to talk about?
Yeah, it was just funny. The team just left because what you said right now is something that's happening right now with one of our TokuDB masters. We just promoted one of our replication topologies to TokuDB, and it seems like there's a lot of deadlocks. So everything is idempotent, fine, but we do get a lot of these deadlocks. So
yeah, I think that read committed can actually deadlock more because it locks less initially. Then there's more things happening at once, more chance of conflicts.
That's actually an interesting point. Okay, well at this point I think it seems like kind of everyone's a little kind of dry on stuff to talk about at this point, and I'm actually running out of ideas right now. So it might be a good time to listen for topics for next time. If anyone has things they want to talk about or present, that would be totally awesome, and I'd love to hear any of those. So I think I'll just start by putting down maybe some additional talk about sharding and potentially Fabric. I'll try to get Gavin in here since he's set it up in an AWS environment that we're running, and see if he can talk more about just his experience with it and building kind of an automation around it to set it up with Puppet.
I'd like to raise the issue of credentials. How do you set up your MySQL credentials? How do you store them? How do you pass around the passwords? Who in your company sees the passwords? Stuff like that.
That's a tough one.
Yeah.
How do you store them? Who can get to them?
I think everyone's going to lie. They're going
to. No one's allowed to say the actual answer.
Yeah. Okay.
No, that's a very good point, and that's just that's a good call, just kind of around just grant management too. Cool. All right. What else do folks want to talk about?
Sorry, Jeff, when you were talking about Fabric, is that MySQL Fabric or Python Fabric that you were talking about?
MySQL, yeah, MySQL Fabric. Sorry,
Okay.
I forgot there's a Python Fabric.
Yeah, we use Python Fabric, so I always get confused when people talk about Fabric, but I assume that's the one you were talking about.
So actually, real quick, do you use Python Fabric for any MySQL management?
We use it for our, not management per se, but we use it for our release process.
Okay.
So, obviously there's a MySQL component to that. But we use Chef for configuration management on MySQL.
So what you're saying, Ike, is that in theory you could Fabric.
You could Fabric, yeah. I don't know that would be a
What's
good
a
idea.
fabrication?
Oh my goodness. What else do folks want to talk about? So I've got more talking about sharding potentially with MySQL Fabric. Talk about credentials, setting them up, storing them, who can see them, kind of just management of that. What other things do folks want to talk about? Everyone's so quiet.
It's my my thinking that's quiet.
I would talk about gaps. For example, how do you know when you've hit that like 80-20 threshold, right? What's easy, what's not under that? That might be kind of a vague topic, but I find myself more and more like our MySQL stuff is kind of tight and we're focusing in other places because there are some little things here and there, but for the most part, things just work.
Are you talking about just resource gaps or kind of capacity planning, or?
No, more. I mean, more like when do you stop working on stuff? When is stuff not important, right? Right? Like, is it really important to get every single last checksum error gone?
Right.
You know, when do you, and this might be kind of tolerating failure, right? But there are some things where we're just like, you know what, ignore that sessions table. Just don't checksum it because there are problems, but it's not worth spending 3 hours debugging it because it doesn't matter.
Okay,
Even
so go ahead, Morgan.
to paraphrase that, Sheree, I think it's interesting. What do you consider a sub-optimization? Because is it a problem, and then is it relevant? And certainly I agree with you that there's some things that are not relevant, and it becomes a skill to decipher that.
Yeah, I don't know how much of that is really a discussion topic, but maybe just talking about like what have you decided that's relevant or not relevant.
No, that's really good. And actually, something that can tie in with that is effectively when do you stop automating and just accept a manual process somewhere?
Yeah,
There's also something else that ties in.
I was just thinking about it today, the difference between int and small int, and when's it important to use the small int? For example, is that optimization important? And I ran through some examples, and in many cases, it's actually not when I tried to simulate some data.
Okay. Cool. It's a pretty good set of things that I think we can actually run on. Anything else before we wrap up today? Any other topics that folks want to hit in the next session or two?
Maybe in the future, I'm not sure if you've had one recently, but a recap on what's coming in MySQL 5.7.
Sure, that sounds good. Would you be willing to do that?
Sure.
Okay.
And Jeff, I saw sharding on the agenda for today. Did I miss that, or is that?
No, we definitely kind of stretched on talking about failure handling. So sharding we're bumping it next time, and hopefully we can get some more talk around MySQL Fabric and people who are using it.
Yep. Great.
Okay.
I would also say pretty soon MySQL Connect stuff is going to come out. So maybe an overview of that. Like I know I was just looking at OSCON data stuff, and we just did a podcast on that. I don't know how relevant that would be, but to kind of talk about stuff like that, because that includes things like the roadmaps.
It's not MySQL Connect anymore.
Oh, right. What's it called now?
MySQL Central at OpenWorld.
There you go.
One more time. MySQL what?
Central.
MySQL, yeah.
Central.
Gotcha.
The cool part is that it means that your ticket will get you into all of the open world events.
Yeah.
So including like the thank you concert with all the big name people.
Cool. Okay, I think that's a good set of stuff for us to operate on next time. So beyond that, thanks very much for everyone who came today and contributed to the conversation, and we'll see you all in 2 weeks.
All right, great.
Thank
Thanks.
you.
Bye, everybody.
Thank you.
Yeah. Bye.
Take care.